Well, I just ripped out the power today.
What kind of power supply did you say it was?
It's a 70 amp switching power supply,
Okay.
but I've got two radios to run. So
How many watts do you normally run at?
uh, on uh, Yaesu, the HF, I'm running 100 watts,
Okay, gotcha.
although I drop that down as necessary. I do have a KPA 500, so I can go to 500 watts, but not all that much. Well, Mr. Wilson didn't like us.
Oh, that's too bad.
He may be fighting, trying to get it connected.
Yeah, that's fine.
So there's the power distro panel for it.
Oh, very nice. Yeah.
Those are all Anderson power poles.
Yeah, absolutely.
And uh, fuses.
Yeah, I need to start using Anderson power poles. I remember Mark's presentation. It seemed like really nice, handy to have, and makes it really clean installs.
Well, everything I've got's Anderson.
Yeah.
The tricky thing is trying to uh, make sure that your Anderson power poles are the same uh, order as everybody else's.
Oh, gotcha. Like the flip the right or the black and the red.
Exactly.
Okay. Yeah.
Well, I mean, no, when you put it, they have an orientation for up and down. I mean, then you have to worry about, do I have this side red and this side black, or this side black or this side black and this side red? You could,
Oh,
because
okay.
they're designed, you can flip them.
Yeah. Okay.
So, what is the meeting tonight? I didn't.
Karen Thompson is the general manager at RT Systems, so she'll be giving us some information on that program. Yeah. Should be pretty good. Hear pretty good stuff about that software.
I have a copy of it someplace for one of my radios. I just don't remember where I
Okay.
have it.
Yeah.
That's been one of the problems with moving from the old PC to the new one, is transferring everything. And so, like the logbook of the world certificates
Certificates.
and
Yeah. That's right. Yeah. Hello to anyone watching on YouTube. There's just a couple people, so it's not much conversation for this evening. But if you want to join in, w0tx.org/meet.
I have one of the little soda beam whisper transmitters, little 200-watt transmitter, and I've been running it on the vertical regularly. But one of the things you have to transfer is the key, so you can get into the website.
Oh yeah, Whisper is, I guess, internet based, so there might be. Huh. You hadn't played around with those before. Huh. So this is a propagation antenna tester. Interesting.
Yeah. So that's the website. So let me go to the table, and there's the top 10 uh, in a week. Let me go to save the last day. And I was hitting somebody at 17,000 kilometers, EPOPOL. They saw me 5 times in the day.
Oh, wow. That is pretty far. Jeez.
Well, if I go, I can go to the spots map. And that's in the day. That's everybody that's been able to see me.
It's just automatically sending out every once in a while transmissions?
It has this weird random system. It transmits at 2 seconds past the even minute sometimes. It doesn't do it every time. It has a random system. It happens to be transmitting right now. Jeff Irvin.
Hey, Jeff.
Hey, Al. We had a meeting to discuss DRC Saturdays, so a little late.
Oh, no problem. You guys finished up that? Looks like people are trickling in here. Yeah, okay.
We got a schedule put together and some ideas, and all's good.
Very cool.
Any Adron, I'll get out of this, but that's what it is.
Yeah.
Tom, we haven't seen you for a while.
Oh, I get busy every once in a while. There we are. I'm back.
Sounds good.
Well, I gotta hop out and zap some dinner real quick, and I'll be right back.
Sounds good. Yeah, just us on here. Not too much going on yet, so Kevin or Jeff, if you have anything else, or anything, or Tom, if you have anything.
I was going to say, by the way, that I'm transmitting on 20 meters.
Oh, okay.
So.
Well, I can bring up a few things here and see if some other people join.
I did get the new ARRL antenna book.
Oh, is that out?
Yeah.
The 25th edition. Yeah.
Yippers. There it is. It's not one that you really want to take to your to read in bed, trust me.
No. Yeah, some light reading, I'm sure. New projects, new information. Very cool. Have you read anything in there yet?
A few things. But I haven't, again, I have so much to keep me busy that I don't even want to think about it.
Gotcha. Okay. All right, well, what do we have here? So more people would join here. We usually have more than this. I guess it'll just be for posterity. How to operate a 500 kilowatt transmitter. Crosley was a famous name in radio for more than one reason. National VOA Museum of Broadcasting has a video telling Powell Crosley's Powell Crosley Jr.'s story and the story behind the 500 kilowatt WLW AM broadcast station transmitter. First, all right. 1922 moved business location along with 500 watts of output. Let's see, until it was finally a 500 kilowatt giant. Technical point of view, these old tubes with 100,000 watt plate dissipation are truly amazing. Several of them in 50 kilowatt transmitters. So, yeah, pretty interesting video here.
Although the WLW 500,000 watt transmitter officially went on the air in 1934, we must begin some years earlier with a bit of background on the man behind this project and the events leading up to its inception. Powell Crosley Jr. was born in Cincinnati, Ohio in 1886 and grew up in the College Hill area of the city. In 1921, he became interested in radio when the first broadcasting stations went on the air. His son wanted a radio receiving set so he could listen to this wonderful new invention. When Mr. Crosley took him to the neighborhood radio store to buy one, he found out that the cost of a commercial receiver was $130, a lot of money at that time. So instead, he bought a book on how to build a receiver. When he and his son built a crystal set and began listening to the few stations then on the air, he was dismayed at the irregularity of broadcasts and the poor quality of programs available. In addition to the presently available,
So that's a 30-minute video.
Being too
Check that in your time.
he was
Might play a little bit more of it
acutely aware
if no one else joins here too soon. But
Yeah, I actually have seen it, and it's very interesting. You know, the reason they shut it down is because Canada complained.
really,
Yeah, it was hitting Canada real hard.
you had to shut down what? Oh, the
WLW.
Gotcha.
The 500 kilowatt.
Okay. Yeah, that's pretty interesting. Wow.
Well, it was drowning out a number of Canadian stations on the same frequency, so Canada didn't like it bleeding over.
Oh, okay. That's interesting to hear. Let's see. Yep. Equipment from the manufacturing companies is such great power that concert emanating from Cincinnati will be heard as far as a distant point in Canada. Well, let's see.
They used modulation transformers. And Kevin Schmidt sending us links. And there were pictures in there of the transformers he used to do the audio modulation, and they were they looked like something you would see for high power tension line.
Okay. Very cool. You'll have to do a little bit more research on that. Just saw that the other day here. You'll have to watch this. Let's see what Kevin put in here. Oh, very cool. Yep, this is a pretty interesting radio. Has a lot of different functionality. The Quansheng UVK5 and K6. You can update the firmware and do quite a lot with it. It looks like another feature is off-grid messaging. So that's pretty interesting stuff here. Let me see here.
range than intended. This is the Quansheng UVK58. It is an extremely cheap dual-band handheld radio, but unlike similar radios before it, this might be the most hackable radio. I like handheld radios, and I've got quite a few of them. Previously, radios were mostly really expensive, but within the last decade, the radio hobby has been made much more accessible by the huge influx of cheap Chinese handheld radios. Most of them have been quite boring though, but with the advent of this new radio, we're seeing the next generation of exciting radios and possibilities. I actually quite like the design of this radio. It's not very big, it's easy to hold and operate, and it has an attractive large monochromatic screen with an amber backlight. The feature I find the most interesting though is this little messaging app, especially the version found on this specific firmware. Through AFSK modulation you can send messages between radios and be texting like you were using an old Nokia phone. Both radios need to have this firmware installed and to monitor the same frequency, which will be used to transmit the messages on. The Messenger app can be opened by pressing F and the big M button. The receiving radio doesn't even need to have the Messenger app open. It just needs to monitor the frequency. If it receives a message, you get an audio notification and a small message icon appears in the top of the screen. If the message you've sent has been received, the receiving radio even automatically returns a confirmation signal, and you will see a plus sign next to your message, letting you know whether it has arrived or if you need to try again. The letters are arranged in the typical phone layout, symbols on 1, ABC on 2, DEF on 3, and so on. Press 0 to create a space, and F to backspace. The star symbol cycles between uppercase, lowercase, and numbers. The up button recovers the last sent message, and the M button sends your message. If you accidentally exit the Messenger app while typing, don't worry, it has saved the message you were working on. It even saves the previously sent and received messages. Hold F to clear the message history. The range of a 5-watt VHF or UHF signal is potentially many kilometers, with the right antenna and antenna height. One unfortunate thing about the messaging app is that the buttons doesn't have the letters printed on them. So even though I grew up typing on these kinds of keyboards, I still have to think twice once in a while. Also, you cannot define a call sign or a nickname, so if you're more than 2 people communicating at the same time, it gets confusing and you have to sign each message manually. This specific firmware by Hua.
Very cool. Yeah, that's a pretty cool looking, radio. I think it's $20-$30 and a lot of features and functionality. Very cool. Cool. Thank you, Kevin. Yeah, I was thinking about getting one of these, because they're also AM or airband as well, I believe. So you can receive airband radio aviation. Cool. Yeah, let's see. All right. Welcome everyone here. There's just half a dozen or so people on here. Appreciate that. Another 30 minutes. This is the Elmer Session. Good place to learn, talk about ham radio, STEM topics. If you have any projects you're working on or want to share anything. Otherwise, we can just keep waffling on here a little bit. What else here? Pretty interesting article. I have not read it yet thoroughly, but seems like it would be right up the alley of what we're doing over on Hackaday. Titled Needing a Refresher on RMS. If you mostly deal with DC current, you might not think that much of root mean square or RMS measurements. You may have seen those on meters have true RMS settings, but what does that mean? There are two things to remember when working with RMS. If you put, say, 100 volts DC through a 100 ohm resistor, you'll draw 1 amp and use 100 watts of power. However, since AC gradually makes its way to a peak value and then starts ramping down immediately, you can't use the peak value or anything like it to figure out AC power. After all, the voltage is only at the peak for an instant. That's where RMS comes in. 100 volts AC RMS through a 100 ohm resistor will also consume an average of 100 watts over time. The other thing to remember is that we use shortcuts for sine waves, where we take the peak voltage and divide by the square root of 2. That only works for sine waves. For anything else, you either need to use hairy math or some way to directly measure the power. RMS is one of those details a lot of people miss, so they've seen a lot of explanations. I'll play a couple minutes of this video here.
Did you know that the voltage of the electricity in your home undergoes rapid changes? This is because the electric current alternates its direction continuously, creating what we call alternating current. If you were to graph the voltage over time, it would resemble a wave-like pattern, similar to a sine graph in trigonometry. Hence, we refer to this waveform as a sinusoidal wave. If the voltage is continually fluctuating, you might wonder why we use standardized values like 120 volt in Canada and the USA or 230 volt in places like England or India. What do these numbers signify when the voltage is in a constant state of change? You might assume that the voltage number represents either the highest peak or the average it reaches. However, that's not exactly the case. Enter RMS, root mean square, a fascinating concept used to measure voltage and current in AC electricity. Observing this basic circuit, there is a light bulb with resistance R. Once a direct current power source is connected, the bulb illuminates. To determine the current flowing through the circuit, we apply Ohm's law. Current equal to voltage divided by resistance. By rearranging this equation, we can compute the voltage is equal to current times resistance. Let's assign numbers to these two equations for reference. If we create a graph depicting both the voltage and current for the bulb, it will result in a straight line. You see, with direct current, both parameters remain constant throughout. Therefore, to determine the power consumption of the bulb, we simply multiply the voltage by the current. Simple, right? This represents our third equation. We can take the third equation and the first one to derive a new equation. Power equals the voltage squared divided by the resistance. Similarly, using the third equation with the second one allows us to derive another new equation. Power is equal to the current squared times the resistance. Keep these in mind. These two equations will be utilized later.
All right, well, you can watch that on your own time. There's another 5 or so minutes of that. Pretty good math-heavy hobby we have, so it's always good to go back to the basics. All right. Well, not many people on here, but we've updated our website, or it looks fairly similar, but it's on a new platform, so it should be a lot quicker and more stable. So if anybody's ever interested, check that out. We'll have a presentation coming up here, 25 minutes, by Karen Thompson, KD4DXX. She's the general manager of RT Systems and will be giving us an intro and background of that software or that organization, as well as dive into the software and hardware used for radio programming. What else?
Want a trivia?
What's that?
Want a trivia question?
Yeah, go ahead.
In your house, you got household current there, right? AC. How fast do the electrons actually move in that wire?
It's not 300 million. What's that? Go ahead, Kevin.
They don't move.
They do. It's slight. It's called a drift speed. It's about 1 millimeter per second. The charge moves a heck of a lot faster than that, but the electrons don't move. And to really throw you, they keep reversing direction every 60 times a second. So the electrons in your wire are the same ones that were there when you built the house. They ain't gone anywhere.
That's interesting. Yeah, it was always a bit heady for me, some of this stuff, but pretty cool. I'm very interested in quantum. I'm really hoping, or I don't know what to expect of quantum computing and quantum mechanics, and it's an exciting future, though, at least, it seems like. Okay. Anyone else? Any other comments, questions? Few people here in the chat. I see Alex and Larry and Jerry and yeah, appreciate people joining here. Ron just joined here. Thanks for joining here. Another 20 minutes. It's been a fairly quiet evening here so far. If you missed this or the meeting, youtube.com/Denver Radio Club. You can always watch it after the fact. But I'll throw it out to the group. Anyone else? Go right ahead.
I did have a question for Larry, but I see him getting up and moving. Larry, are you still teaching over at Mines? Oh, hang on. Larry, are you there? I think you're muted. I can't tell if you heard me.
Hey, Larry, you're on mute, I think.
Oh, there we go.
How about now? Can you hear me?
Yeah.
Yep.
Larry, I was wondering, are you still teaching at Mines?
Well, I don't teach formally.
Oh. Okay.
I do maybe do a special session to teach some software or how to use the computer systems, like that, whether it's a group or individuals, depends on the circumstance.
Okay. Well, I was just curious about their ham club. I think the last time I heard from you, you guys might have been starting it up, or there's some sort of push to maybe get that moving. I was just curious saw you on here and figured I'd ask to see if that ever took off.
Well, we need 15 people to sign up to get it to go again. And that has to be students. So anybody that's not a student is helpful. And I can be the faculty advisor for the club. That's not a problem. But we just can't find enough people that are interested in it. We don't have a big enough circle of them, of the students. I mean, it's an engineering school. They're more, although if we could get some of the people in the electrical engineering that are interested in radio per se, like things like Wi-Fi, stuff like that, we might be able to get some crossover. At one time, I had one of the professors there that was interested in letting me come in and do a little marketing project to try to get people into amateur radio, but he has retired and we haven't found a new Wi-Fi professor yet, but I'll keep checking with the department heads, see what's going to happen over there. I know a lot of the department heads just because they know me, so I know a lot of who they are and I can talk to them about it.
Well, that's all cool. I just figured I'd follow up. Really, there's a very selfish motivation here, which is if they have a nice station, wondering if we could get in there for a contest weekend or something.
I don't even. I don't even know if they have any equipment anymore, and where it would be. They do have some um, communications equipment set up for linking up with the mine that's up in the hills, and so they have some two-way traffic that goes through that. And I can see the antennas on the building. It's on Brown, which is the electrical engineering building. And it's got they got 3D printers there. You can go in and print a 3D object if you want to. They have some computer science stuff in there. Mining engineering's got some. They've got some virtual reality stuff in there. I've gone and played with it. Actually, went through the mine virtually, and I had gone to the mine in reality. And then when I did the virtual, I said, "Oh, I know where I am." It was pretty cool.
That does seem cool.
Yeah, they want me to get some virtual reality stuff going for both geology and geophysics departments. And the geophysics departments, I know what I'd like to do with it, but I can't seem to get anybody to go for it. The on the geology side, it's really easy because they want to do things with drones and things where so if you have a handicapped person can't go out in the field, they got to have a drone go up a side of a cliff and look at the rocks, and they can look at those rocks and kind of get a feel for what's going on. That would work pretty well. I could think of a lot of instances where you got a dangerous area that you don't want to go rock climbing, but you want to look at the outcrop because it's got some really cool stuff there.
Well, that all seems cool.
Yep. It is cool. And I feel blessed that I got a job there. So in March, we'll have been there 7 years now.
Well, we'll do our best not to screw it up for you if we ever get up there and do some ham radio.
Yep, indeed. In fact, I can hit the DMR repeater on Lookout Mountain from inside the building where my office is. I can hit it from my desk, which I think is pretty cool.
Very cool. All right, we'll have another 20 minutes. Anyone else? Comments, questions? Let us know. All right. Bring up another news story here and keep going on and have the meeting in about 15 minutes. Speaking about radios, Jonathan KM4CFT on the recent Learning Net mentioned he had purchased an Elecraft KH1 transceiver, 5-band, in the form factor of a handheld, but it's HF. So pretty interesting stuff there. KH1, 40 through 15 meters, I think 20 through 15 meters as well. I think it's probably just 5 watts QRP, but it's a pretty interesting looking radio here. Let's see here. Article over on hackaday.com simulating a timekeeping radio signal. As far as timekeeping goes, there's nothing more accurate, precise than anatomic clock. Unfortunately, we can't all have blocks of cesium in our basements. So various agencies around the world have maintained radio stations which, combined with an on-site atomic clock, send out timekeeping signals over the air. One we'll be quite aware of is WWVB up in Fort Collins. It's generally receivable anywhere in the U.S., but can be heard on the East Coast. John Mackey, who lives in northern New Hampshire, built a WWVB simulator. Normally, clocks built to synchronize with the WWVB station include a small radio antenna to receive the 60 kilohertz signal and the 1 bit per second transmission, which is then decoded and used to update the time shown on the clock. Most of these clocks have internal but much less precise timekeeping circuitry to keep themselves going if they lose the signal. John Mackey can go several days without his clocks hearing it. To make up for that, he built a small transmitter which generates the proper timekeeping code for his clocks. It's based on an STM32, which receives its time from GPS and broadcasts on the correct frequency. A small radio transmitter is built using one of the pins on the STM32, using pulse wave modulation to get its frequency exactly at 600 kilohertz, which can then have data modulated onto it. The radiating area is much less than a meter, so this isn't likely to upset any neighbors, the NIST or the FCC, and the clocks need to be right beside it to update. Part of the reason why range is so limited is that it uses VLF radios typically require enormous antennas to be useful. So if you want to listen to more than timekeeping standards, you'll need a bit of gear. So over on Instructables.com, has the instructions and supplies needed to build a WWVB simulator. Similar to this, and we were talking about Canada a little bit earlier, is they have or did have a broadcast from the National Research Council time signal. It was turned off on October 9th. After 84 years, let me see, one more time signal consisted of a series of 800 hertz sine wave beeps followed by a second long signal to indicate the top of the hour. But it has been decommissioned. All right, anyone else? We have another 10 minutes or so. Comments, questions, any projects you're working on, anything you want to share, let us know here. Let's see if I have anything else here in the meantime. Yeah, I don't have much else. I can bring up a couple other things, but let's see, we could do some window shopping. Tindy.com, if you're interested in just electronics projects and kits. It's a pretty cool site to kind of browse. Let's see here. Ink displays are pretty fun to play around with. Have not messed around with them myself, but really low power and can last a while on very little battery usage, and pretty fun stuff there. See over on reddit.com/r/amateur radio, someone was asking a question of a decade or so ago. They remember EasyPal being very popular for sending and receiving digital slow scan television on 20 and 40 meters. They were wondering if there's still digital SSTV on HF. Looks like on 14230 people are using that. And again, if you haven't seen it, single scan or slow scan television. It's basically just an image transmission system over radio. The ISS will often send it out. Russian compatriots, RS-0 ISS, are known to send those out quite frequently. So if you're ever interested in receiving images from the International Space Station or transmitting images to other radios, so pretty cool options here.
It's a lot better than it used to be. Back when
Did
you
it?
used to have, 40 years ago, you had CRTs, and remember, it's very, very slow in scanning, and you would crank up the gain on the thing so it would really blast your tube and be very persistent, because oftentimes the top of the image would disappear before you got the bottom. It would fade away.
Hmm.
So you would use a Polaroid camera and let it scan the whole thing, and then close the shutter and pull the Polaroid. Computers made it much nicer.
Wow. Yeah, absolutely. Yeah. And there's Android apps, and you can just put your phone right up to your HT, and it'll just decode it. It's pretty cool stuff. Let's see. Method for picture transmission used by amateur radio operators to transmit and receive images. Most popular SSTV modes: Robot, Scotty, and Martin. Technical term for SSTV is narrowband television. Analog broadcast television signals require 6 to 8 megahertz of bandwidth because it transmits 25 or 30 pictures frames per second. SSTV usually only takes up a maximum of 3 kilohertz of bandwidth. Much slower method of still picture transmission, usually taking from about 8 seconds to a couple minutes, depending on the mode. Uses analog frequency modulation. Every different value of brightness in the image gets a different audio frequency. Other words, the signal frequency shifts up to create a brighter pixel and shifts down to create a darker pixel. Color is achieved by sending the brightness of each color component, RGB separately. More technical stuff here. It's been used in popular culture. Yeah. I can play a bit of audio of it. It is a little screechy, so I'm not going to play too much of it here. But it is distinctive. So. SIGIDwiki.com if you haven't seen it before. Pretty cool site to go look up signals, what they look like on waterfalls, and what they sound like. So, pretty cool options there. All right, another 5 minutes or so. Let me see if Karen's here yet. Okay, I do not see Karen yet in the chat here. I wonder if the DRC Saturday committee wanted to share anything. I should have asked earlier, but we have a few more people. If you guys want to bring up anything on that.
I can add something if you like.
Yeah, good.
We'll see. I'm trying to find it. I'm trying to do two things. So we have, come on, computer. We were successful in our meeting in that we established the days of the DRC Saturday and a rough outline of what we're thinking of doing. So there are 5 events this year instead of 4. We're adding another one. April 27th, and this will all be on the website, but we just got done with the meeting.
Yeah.
So April 27th is going to be the first one, and it's going to be a build day. And we're going to pick something to build, probably an antenna or something. And prior to that day, we may do some kind of presentation during this meeting of whatever we're going to build, so people can understand what we're going to do, and then they can come out and we're going to build something. May 25th, we're going to do a Pico balloon for DRC. So we're going to go launch a balloon, and then we're going to go out and chase it down, a DRC balloon. Nothing in June because we have field day in June. July, we're doing POTA activation again on July 20th out at Barr Lake this time. It's a state park, so there is an entrance fee, or if you got your registration and paid the extra fee for the state park thing, you can get in free. Then on August 31st is the Colorado QSO party, and so we're going to set up a few DRC station, kind of like a mini field day, but it's going to be all about Colorado QSO party, and we're going to have an entry into that and have people come out and play radio and see how many contacts we can get for Colorado QSO party. And then the final one is October 5th. We're doing what we're calling the DRC Campout. And we're going to do this will probably be a 2-day event where we'll go out, and we're already kind of identified a place near Gross Reservoir where we'll reserve some campsites and see if we can get people to come out and spend a couple days playing radio and getting out away from all the RF noise, and should be a good time. So that's it. That's what our DRC Saturday for 2024 looks like.
Excellent. Good to hear. Yeah, glad to hear we got some dates set up and some activities going. Awesome. Thank you. Saturdays though, still, yeah.
Yeah, all those dates are Saturdays. So DRC Saturdays, we just have different activities associated with each one of them.
Yep. Okay. Gotcha.
Would it be easier if we switched one or two of those to Sundays? Doron, do you have any sense?
I just know they couldn't make it on Saturdays. Some people.
Okay.
Yeah.
Well, we've got many, many months until the later end of that schedule. So
yeah.
Something we can take back and consider.
Sounds good.
We also have something we're considering. We're calling it like a pop-up event. So we have a lot of ideas, and we've received a lot of ideas. So it's fantastic. It's a great problem to have. So we may be doing a pop-up event where you'll get a notification during the week, and it might be a Sunday, it might be a Friday afternoon, it might be a Monday afternoon, but it's going to depend on whoever is going to manage that pop-up event of what they want to do. So there's all kinds of different things that we have teed up for that.
Very cool. Sounds good. I'm sure people will definitely like that. All right, we just got a couple more minutes here. This has been the Denver Radio Club Elmer Session. It's been a little bit quiet this evening, but you can watch it back over on YouTube if you want, youtube.com/Denver Radio Club. We'll also have our meeting on there as well. I don't see Karen has joined yet.
Yeah, I pinged her via email, but I haven't heard back, so I hope she shows.
Okay. I'll see if I have any last minute quick things here, but I think that might be it for the Elmer Session. Just ticked over to 7 p.m. All right, everyone watching on YouTube, I'm going to go ahead and drop the Elmer Session.
Okay, Jerome.
And then start it again for the meeting. We'll see you in a minute.
Thanks for doing all. It sounded like you had a real